Jayshri working as an assistant professor of chemistry in KTHM College, Nasik. Today's session is useful for MSc first year and MSc second year student, MSc first year for second semester and MSc second year also for first semester. Today we learn the transition metal-carbene complexes. Today's session agenda is the types of metal-carbene complexes. Then the bonding in metal-carbene complexes. Hello student, today we discuss the transition metal-carbene complexes. When the metal bonded with carbon with double bond is called as a metal-carbene complexes, or it is also called as alkylidene complexes. Generally, the carbon having valency 4. This carbon have 4 bond form करू शकतो. When the carbon atom already bonded with 2 atoms, these 2 atoms are same or these 2 atoms are different, and the pair of electron in present on carbon atom for the bonding with the metal atom. This divalent electron pair is distributed in different orbitals or same orbitals of the carbon, that is the sp2 hybrid orbital or 2pz atomic orbital. According to that distribution of that electrons in sp2 hybrid orbital or 2pz atomic orbital, the carbene having 2 types, that is singlet carbene and the second one is triplet carbene. Singlet and the second one is the triplet carbene. Singlet carbene having the no unpaired electron, that is 2 electrons are present in sp2 hybrid orbital. In singlet carbene, there is a no unpaired electron and 2 electrons are present in the sp2 hybrid orbital. In triplet carbene, there are unpaired electrons. 2 unpaired electrons are present in sp2 hybrid orbital. sp2 hybrid orbital मध्ये 2 unpaired electron असणारे ट्रिपलेट कार्बन मध्ये, आणि सिंगलेट कार्बन मध्ये there is a no unpaired electron and the paired electron is present in the sp2 hybrid orbital. We see the diagram for that singlet carbene and triplet carbene. This is the vacant 2pz atomic orbital. This is vacant 2pz atomic orbital of singlet carbene, and this one is sp2, that is filled sp2 hybrid orbital or hybrid atomic orbital of the singlet carbene, and bonded with the 2 different or 2 same atoms, that is the X and Y. Here interelectronic repulsion in that singlet carbene is greater, and therefore the bond angle X, C and Y is smaller. This interelectronic repulsion is greater, and therefore the bond angle is smaller. In triplet carbene, 2pz atomic orbital is singly occupied and sp2 hybrid orbital is also the singly occupied. 2pz singly occupied and this sp2 is also singly occupied, and these are the x and y. Here inter-electronic repulsion is smaller, and therefore the x carbon and y bond angle is the larger. Then how it is called as a singlet, how it is called as a triplet, we see one by one. First we see the singlet carbene. In singlet carbene, there is a pair of electron. When we calculate the spin angular momentum quantum number, that is S is equal to summation of ms1 plus summation of ms is equal to ms1 plus ms2. It is here pair of electron present means one electron having spin plus half, one electron having spin minus half, that is plus half minus half is equal to 0. Then we calculate the spin multiplicity. Spin multiplicity is equal to 2s plus 1. The s ची व्हॅल्यू काय असणार आहे, 0. That is 2 into 0 plus 1. वरती घ्यायचं का हे पूर्ण का आता मल्टिप्लिसिटी पासून परत एकदा लिहिले तर चालेल का? इथे एका लाईन मध्ये लिहिते बर. देन करूच तर. Then spin multiplicity is equal to 2s plus 1. Now the s is 0, that is 2 into 0 plus 1 is equal to 1. Therefore it is a singlet carbene. Now we discuss about the triplet carbene. Now we discuss about the triplet carbene. In triplet carbene, the spin angular momentum quantum number is equal to S 2 unpaired electrons. 2 unpaired electrons means both having the spin plus half is equal to 1. S value is 1. Therefore, spin multiplicity 2s plus 1 is equal to 2 into 1 plus 1 is equal to 3. 3 means triplet, and therefore it is called as a triplet carbene. Generally, the transition metal carbene complexes having two types, that is heteronuclear carbene complexes and the homonuclear carbene complexes. Generally, the metal carbene complexes are of the types LNM double bond carbon R and R dash. Ln means number of ligands, metal and carbon attached with two different groups. These two different groups are the heteroatoms or hydrogen or carbon. Depend on that R substituent. These metal carbene complexes having two types, that is heteronuclear carbene complexes and the homonuclear carbene complexes. We discuss one by one. First we discuss the heteronuclear carbon complexes. When that R group, that is the substituent on carbon atoms, are the heteroatoms, then this is called as the heteronuclear carbon complexes, or it is also called as Fischer carbon complexes. यालाच काय म्हटलं जातं? Fischer carbon complexes असेही म्हटलं जातं. When the substituent on carbon atoms are OCH3, then NH2, then Mu2, that is the pi donor ligand. When these are the pi donor ligand present on carbon atoms of metal-carbene complexes, then these complexes are called as the heteronuclear carbon complexes or the Fischer carbon complexes. In that Fischer carbon complexes, the carbon of that carbon complex is electrophilic in nature. Generally, the metals are more electrophilic than carbon. That is, carbon is more nucleophilic than metal. But because of that pi donor ligand present on the carbon, this carbon becomes electrophilic in nature. Then these complexes having low oxidation state. Metal in that complex is having the low oxidation state. Then these complexes follow 18 electron rule. 18 electron rule follow करतो म्हणजेच ते complexes कसे असणारे stable. Follows 18 electron rule and these complexes are very stable than the homonuclear carbon complexes. Then the metal of that metal carbon complexes having substituent are pi acceptor. That is, the ligand present on the metal atom are pi acceptor ligand. That is the CO, then Cn minus. These are the pi acceptor ligand. And the substituent, that is R and R dash, present on the carbon atoms are generally pi donor ligand. Pi donor substituent. For example, OCH3. Then NH2, these are the pi donor substituent. These are the some characteristic features of heteronuclear carbon complexes. Then homonuclear carbon complexes. In homonuclear carbon complexes, this substituent R and R dash are only carbon and hydrogen, and therefore these complexes are called as a homonuclear carbon complexes. किंवा ज्याला श्रॉक carbon complexes असेही म्हटलं जातं. It is also called as a Schrock carbon complexes or homonuclear carbon complexes. Homonuclear carbon complexes का म्हटलं जातं तर इथे कुठलाही heteroatom present नसतो. Only the carbon and hydrogen groups are present as a substituent on carbon. Therefore, it is called as a homonuclear carbon complexes. Now we discuss some characteristic features of the homonuclear carbon complexes. जसं तुम्ही बघितलं फिशर कार्बन कॉम्प्लेक्सेस मध्ये जे कार्बनचं नेचर आहे ते कसं असणार आहे इलेक्ट्रोफिलिक इन नेचर बिकॉज ऑफ दॅट पाय ऍक्सेप्टर लिगॅंड प्रेझेंट ऑन द मेटल अँड द पाय डोनर सबस्टिट्यूएंट ऑन द पाय acceptor ligand on the metal and pi donor substituent on the carbon atom. This carbon becomes the electrophilic in nature. But in Schrock carbon complexes, there is a no pi donor ligand or pi acceptor, pi donor substituent or pi acceptor ligand present on the metal and carbon respectively. Therefore, naturally जसं कार्बन हा न्यूक्लियोफिलिक इन नेचर असतो, कार्बनचे निगेटिव्ह चार्ज हा कार्बनकडे जास्त असतो. Therefore, this carbon is nucleophilic in nature. When the metal having the high oxidation state, variable oxidation state forms that type of complex. That is metal in that complex having the high oxidation state. Then third point is it does not follow the 18 electron rule. That is These complexes having high oxidation state and electron rich in nature, and therefore electron deficient in nature, and therefore they only having the electron species is 16, 17, that is they not follow the 18 electron rule, and therefore they are less stable comparatively to the Fischer-Carbon complexes. जनरली आपल्याला माहिती आहे 18 इलेक्ट्रॉन रूल जे कॉम्प्लेक्स फॉलो करतात तेच कॉम्प्लेक्सेस कसे असणार आहे, स्टेबल असणार आहे, and these Schrock carbon complexes does not follow the 18 electron rule and therefore they are the less stable. Then the next important point is the substituent on carbon atoms are not pi donor. Substituent on carbon atom are non-pi donor, and the ligand present on the metal atom are also the non-pi acceptor. Non-pi acceptor, and therefore these ligands, this carbon is nucleophilic in nature. Generally जे Fischer-Carbon complexes फॉर्म करतात ते क्रोमियम अँड Fe फॅमिलीचे जे मेटल्स असतात, these metal complexes, metals form the such type of complexes. आणि इकडे निओबियम असेल, टॅन्टॅलम असेल, these type of metals which having the variable oxidation state किंवा high oxidation state, they form the Schrock carbon complexes. Now we discuss the bonding in Fischer-Carbon complexes and the Schrock carbon complexes. The singlet carbon form the Fischer-Carbon complexes. The singlet carbon हे Fischer-Carbon complexes फॉर्म करत आहे, म्हणजे कार्बनकडे काय असणार आहे तर completely filled sp2 hybrid orbital असणार आहे. These completely filled sp2 hybrid orbitals overlap with the empty d2 sp3 hybrid orbital atomic orbital of the metal atom forms the metal carbon sigma bond. Now such a type of overlapping takes place. This is a empty or vacant d2 sp3 atomic orbital of metal, and this is a filled sp2 orbital of the carbon atom, and forms a metal Metal-Carbon sigma bond. At the same time, the filled 3dxz or 3dyz atomic orbital of the metal atom overlap with the empty 2pz atomic orbital of the carbon forms the pi bond. This is a filled 3dxz or dyz atomic orbital of metal, and this is a vacant 2pz atomic orbital of the carbon overlaps and forms the metal carbon pi bond. मेटल कार्बन पाय बॉन्ड. आता पहिले कार्बन इलेक्ट्रॉन कोणाला देणार, मेटलला, आणि काय फॉर्म करतो तो मेटल कार्बन सिग्मा बॉन्ड. तर इकडे बॅक डोनेशन होणार, म्हणजेच मेटल कोणाला इलेक्ट्रॉन देतोय, कार्बनला इलेक्ट्रॉन देतोय. XZ or YZ atomic orbital of metal donates electron to the atomic orbital of the carbon atom and form the metal carbon बॉन्ड यालाच काय म्हटलं जातं तर बॅक बॉन्डिंग, पाय बॅक बॉन्डिंग, बॅक बॉन्डिंग किंवा त्याला काय म्हटलं जातं पाय बॅक बॉन्डिंग. नाउ वी डिस्कस द बॉन्डिंग इन दी श्रग कार्बन कॉम्प्लेक्सेस. श्रग कार्बन कॉम्प्लेक्सेस हे कशाने फॉर्म होतात तर ट्रिपलेट कार्बन. आता ट्रिपलेट कार्बन म्हणजे काय तर sp2 hybrid orbital and 2pz atomic orbital are the singly occupied. मग हे दोघं पण काय असणार आहे singly occupied. These singly occupied atomic orbital, 2pz atomic orbital and sp2 hybrid orbital overlap with the singly occupied orbitals of the metal atom and forms covalent type of bonding. Triplet carbene forms Schrock carbene type of complexes. Then the singly occupied D2sp3 orbital of metal atom when overlaps with the singly occupied sp2 orbital hybrid orbital of carbon atom forms a metal carbon this is X metal carbon sigma bond, or it is a covalent type of bonding. It's a covalent type of bonding. At the same time, the singly occupied 2pz atomic orbital of carbon atom and singly occupied d pi orbital of the metal atom singly occupied d pi orbital of metal overlap with the singly occupied two pz atomic orbital of the carbon forms a carbon metal pi bond. The carbon metal pi bond. Okay, this is all about the transition metal carbon complexes. Transition metal carbon complexes, their types and the bonding of that transition metal carbon complexes. Thank you.